Welcome, fellow travelers of the cosmos. Have you ever gazed up at a star-dusted night sky and wondered about the intricate dance of our planet? Today, we embark on a journey to uncover one of the most fascinating aspects of our world, Earth's axial tilt. This isn't just some obscure astronomical term, it's the reason we experience the ebb and flow of seasons, the life-giving warmth of summer, and the crisp embrace of winter. From its very definition to the hypothetical scenarios of a world without tilt, we'll delve into the science, the history, and the awe-inspiring wonders of this celestial phenomenon. Prepare to have your perspective shifted, for we are about to unravel the secrets behind the Earth's celestial dance. Imagine Earth as a spinning top, gracefully pirouetting through the vastness of space. Now picture this top slightly off-kilter, rotating on an axis tilted at an angle. Instead of spinning perfectly upright, Earth maintains a constant tilt of about 23.4 degrees relative to its orbital plane. This means that as our planet journeys around its stellar parent, different parts of the globe receive varying amounts of sunlight throughout the year. This seemingly simple tilt is the driving force behind our planet's seasonal variations, a celestial choreographer dictating the rhythm of life on Earth. Earth's axial tilt is far from a mere astronomical curiosity. It's the maestro orchestrating the symphony of our planet's seasons and climate. Without it, our world would be a vastly different place. Imagine a world where every day felt the same. No refreshing spring blooms, no scorching summer days, no crisp autumn leaves, and no snow-covered winter wonderlands. As our planet spins on its tilted axis and orbits the sun, different regions receive varying amounts of sunlight, creating the temperature variations that define our seasons. This axial tilt influences ocean currents, weather patterns, and even the distribution of plant and animal life across the globe. Let's embark on a thought experiment, a journey to a parallel Earth where axial tilt is but a distant cosmic rumor. In this hypothetical world, the sun would perpetually shine directly over the equator, casting long shadows and creating a narrow band of intense heat. The poles, eternally shrouded in twilight, would remain frigid and inhospitable, their icy landscapes untouched by the sun's warmth. Without the temperature variations driven by axial tilt, global weather patterns would be radically different. Life on Earth, so exquisitely adapted to the rhythm of the seasons, would face unprecedented challenges in this tiltless world. How do we know Earth is tilted at approximately 23.4 degrees? It's not like we can simply pull out a giant protractor and measure our planet from space. Determining Earth's axial tilt requires a bit more ingenuity. One method involves observing the sun's path across the sky throughout the year. By carefully tracking the sun's highest point at noon each day, astronomers can calculate the angle between the sun's apparent path and the celestial equator. These measurements have revealed that our planet's tilt is not static. It undergoes subtle variations over vast stretches of time, influenced by the gravitational tug of the sun, moon, and other celestial bodies. Earth's annual motion and axial tilt are distinct phenomena shaping our planet's relationship with the sun. Earth's orbit takes approximately 365.25 days, marking a year. Axial tilt refers to Earth's rotational axis inclination. Earth's orbit sets the stage while axial tilt dictates the seasons. Earth's axial tilt is currently measured at approximately 23.4 degrees, a seemingly arbitrary number, yet one that holds profound implications for our planet. This tilt is the Goldilocks angle, not too steep, not too shallow, but just right for life as we know it. If Earth's tilt were more extreme, say 45 degrees or more, the seasons would be far more dramatic. Conversely, a less pronounced tilt, closer to 0 degrees, would result in a world with almost no seasonal variation. It's this delicate balance, this precise 23.4 degree tilt, that allows for the moderate seasons we experience, creating a more hospitable environment for life to thrive. The realization that Earth is tilted on its axis wasn't a sudden epiphany, but rather a gradual awakening of human understanding, a testament to our ancestors' curiosity about the heavens. Ancient civilizations, keen observers of the sky, noticed patterns in the sun's path throughout the year. Early astronomers, such as the Greeks, developed models to explain these observations, proposing that Earth was tilted on its axis and orbited the sun. However, it wasn't until the Renaissance, with the work of Nicolaus Copernicus and Johannes Kepler, that the heliocentric model, with Earth revolving around the Sun, gained widespread acceptance. As astronomical instruments and techniques improved, so too did our understanding of Earth's axial tilt. Long before modern telescopes, our ancestors used ingenious methods to measure Earth's axial tilt, relying on keen observation and understanding of the cosmos. They used gnomons, vertical structures like obelisks, to measure shadows at noon. This helped determine the Sun's altitude and Earth's axial tilt. The armillary sphere modeled the celestial sphere with rings representing celestial circles. These methods laid the foundation for our modern understanding of Earth's place in the cosmos. The question of how Earth acquired its axial tilt is a captivating mystery, one that has puzzled scientists for centuries. While we don't have a definitive answer, the prevailing theory suggests a rather dramatic origin story, a cosmic collision of epic proportions. Billions of years ago, during the chaotic early days of our solar system, a Mars-sized object, often referred to as Theia, is believed to have slammed into the young Earth. This cataclysmic impact ejected vast amounts of debris into space, which eventually coalesced to form our moon. The impact itself is also thought to have tilted Earth's axis, setting our planet spinning at its current inclination. Earth's axial tilt is a celestial timekeeper, marking the passage of seasons and influencing life on our planet. Solstices mark the sun's highest and lowest points in the sky. Equinoxes bring equal day and night lengths. These events remind us of Earth's intricate dance through the cosmos. From the lush rainforests of the tropics to the icy plains of the Arctic, life on Earth evolves with the seasons, driven by our planet's axial tilt. The changing seasons influence biological processes. Plants time their growth and flowering, and seed dispersal to optimal conditions. Animals migrate for food and breeding. Earth's axial tilt shapes life on our planet. While Earth's axial tilt might seem like an unchanging constant, our planet's celestial dance is far more dynamic than it first appears. Over vast stretches of time, Earth's tilt undergoes subtle variations, influenced by the gravitational pull of the Sun, Moon, and other celestial bodies. These variations, known as obliquity cycles, occur over tens of thousands of years, and can cause Earth's axial tilt to vary between approximately 22.1 and 24.5 degrees. While these changes might seem small, they can have a significant impact on Earth's climate over long periods. These obliquity cycles, along with other astronomical factors, play a role in Earth's long-term climate patterns, influencing glacial cycles and other significant environmental changes. Imagine a world without axial tilt, where the sun always shines over the equator, creating a narrow band of intense heat. Seasons would be a distant memory, replaced by climatic monotony. Tropics would experience relentless summer with lush rainforests, but biodiversity would decline as species struggle to adapt. Poles would remain frigid and inhospitable, largely devoid of life. Now, let's imagine Earth's axis taking a more dramatic tilt, increasing to, say, 45 degrees. In this scenario, our planet's seasons would be amplified, creating a world of climatic extremes. Summers in the hemisphere tilted towards the sun would be scorching hot, with the sun high in the sky for extended periods. Winters, on the other hand, would be brutally cold and dark, as the sun barely peaks above the horizon. These extreme temperature swings would have profound effects on life on Earth, with many plants and animals struggling to adapt to the scorching summers and frigid winters. Finally, let's explore a scenario where Earth's axial tilt decreases to a mere 10 degrees. In this world, the seasons would be muted, barely discernible whispers of change rather than the dramatic shifts we experience today. The tropics would remain warm and humid year-round, though perhaps slightly cooler than on our tilted Earth. The poles, while still cold, would experience less extreme temperatures, potentially allowing for a greater diversity of life. However, this lack of seasonal variation would likely have its own set of consequences, with life on Earth facing challenges in this world of muted change. Thank you for joining us on this journey through the wonders of Earth's axial tilt. We've explored its definition, its consequences, and the hypothetical scenarios of a world without it, or with a drastically different tilt. From the changing seasons to the very existence of life as we know it, axial tilt has shaped our planet in profound ways. It's a testament to the interconnectedness of our cosmos, where a seemingly small angle can have a monumental impact on our world. Don't forget to like, subscribe, and hit the bell icon for more fascinating insights into our universe. Until next time, keep looking up.